Hello, my name is Turbine. In this tutorial, we will see on an example of automatic model curation in wind turbine gravity-based foundation. In ICDAS website, at input page, we see the Revit model curate the bottom rib walls supports in project file RVT. It includes also 3D reinforcement automatic curation in the walls. And we curate the cylinder with varying thickness in height in family file, and then we load the family files into the project file. We will also change 3 parameters in input. Here the artwork equal to 0, then we have the polygon cylinder, or the artwork equal to 1, we have the round cylinder. We will also change the number of rib walls support surrounding here. This is the parameter N walls. Now look at the current model in Revit. As the inputs I have here, we have 10 rib walls supports surrounding the cylinder. So the first change we make is to 6 walls supports surrounding the cylinder. I go to input region 2 and modify N walls to 6. In Revit, I go to project browser, Node, select the current family cylinder and hide it. So I can select all existing levels and walls and delete it in project file because I run it again with 6 walls. I go to add-ins, external tools, and create the new. So now I go to the high bottom here, select the family and unhide. So now we have 6 rib walls support surrounding the cylinder, but the cylinder still be in tensile. So I go back to the family file and select all of existing level and delete it. So this is a rule in this family file that it needs at least 1 level left. So I need to rename this level to 0 because ICDAS will create all level automatically. So when I run the family, I have to modify family parameter to 1 in input here. Control self. So every time you run in ICDAS, it will prompt up a windows for you with the key parameter. Here family is set to 1, that means we have to run it in ICDAS mass.afa family file. It will take a few seconds to create the cylinder in 24.25 meter high and with varying thickness along the height of the cylinder. So now it's finished. I select the cylinder and go to Properties, Material, and select Concrete Cast in situ. And then I load this family back to my project. Override the existing version. So now we can see it changed to 6 wall. Now we want the cylinder to be round. So we go back to the family file where we can create varying thickness of cylinder and delete the last one. So before I run, I need to remember to change the artwork parameter to 1. So it will now create the round cylinder for me. The level along the height of the cylinder will be entered in the first region's input here, where the first value is the level at the seabed, and then the next value is the height from the seabed level, and the height from the previous level, and so on. So we load the two projects again, override the existing version. So now we have the round cylinder. So let me calculate on this model. I go to external tools and create a LUSAS CMD file. And in LUSAS, I go to File, Import. This is LUSAS 15 version. So this has a spring support defined in input, or you can modify it here. So I turn off the support icon and try to solve it. So for the test reason between the different parameters, we have only dead loads in this model. So I set active dead load and look at top view. So for example, we will see on the contour of the stress. Before that, I would like to identify the direction of the element. You see also the surface axis. So the x-axis with double arrows, it points in this direction around the bottom foundation plate. So I right mouse click here and choose contour. I see on the stress top SX. Okay. So I drag the mesh down so I can see the position, and then I select element node and see on the values here. Right mouse click on the model name, values, stress top, SX. And we don't want to see the decimal, we turn it off. And then I choose the front. This is the first time, it takes a long time to go to front here. So I prefer to see the front in Korean use, so I clearly can see the minus sign for compression and plus for tension. Maybe it's easy to see with the text turn 90 degrees. So this is the value of the stress SX. If we cannot see the direction of the x-axis, so we drag the geometry to the last line here. So this is the stress for the section perpendicular to the x-axis. So when it stands top, so what is the top? We need to see it in 3D view. The top of the bottom foundation plate here is the z-axis upward. The z upward point to the top direction of the element. So now we interested to see what will be changed here for the dead load if we have a round cone wall support. So I go back to the Revit and ensure I have the model updates in the drawing. So I go to North, and before I change this, I would like to mention that in Revit everything in ICDAS is happened in 3D. That means from the 3D model you have here, you can make any section. Here I have made a vertical section 1. So you can see the varying thickness of the cylinder here. And it's exactly the same here will be modeled in the FEM LUSAS model. So let's measure the distance between the level 5,000, 1,000, 5,700 again. Oops. And the total level, the total height, sorry, is a 24.25 meters. And the height of each floor here, 5,250, 1,000 and so on, is the height we enter in input here. As I mentioned earlier, the first values is the level at the bottom. On the top of the foundation place is minus 20 meters below the water level. And then the 5,200 is the height of the first floor and so on. Now we return to the north view and hide the current cylinder, and then select on level and create. I close the first region here. The cone, now we set the cone distance to 7 meters. This is the distance from the cylinder to the outside of the cone wall support. And then we run it in family, and we set it, no, we run it in projects file, so we set family to 0. And then we create the new level. So now I go to family file to create the cylinder and the cone wall supports below. So I have to ensure that I switch family to 1 here because I run in family, and the cone wall supports 7,000 meters as well. Yes, so I control save the input, and then we run the new cylinder with the cone wall support in family file. It will take a little bit longer time because of the cone wall supports below, so now also create in family. So when we wait, I can show you this is the thickness of the cylinder along the height we enter in input. So if we will increase the level, so we just copy a line and pass it to the new line and modify the height and the associated thickness of the cylinder at that section. And in the third region of input, we can enter the reinforcement, diameter and distance for all of the ripple wall support. Now it's finished. So I go back here. We can see the cone wall support here. Material. Lower to project. Override existing version. So I go to the high bottom here, select the cone wall, unhide in view. So it looks like this. We have made some change of this model. Let me return to the vertical section we have created previously. So it is here. So now we will calculate on this model. We create a CMD file for LUSAS. It will update here. Actually, you do not need to open the LUSAS CMD. So in another LUSAS, I import the new CMD file and try to compare with the previous model. I have the RIP world support below. So I turn off the support, which is very important, but we will look at the support condition in the next time. And then we solve it. Then we look at the top view and do the same again. I go to activate low case, activate dead low, set active. Turn up the icon for load. And then go to the layers tab, right mouse click on the model, open the contour. And we would like to see the same stress top as X direction. So now we would like to see the result on the bottom foundation. So we need to hide the cone wall support here. In attribute, you can see the name of all element. In this case, it's the corner vertical inclining X 18 element and Y 6 element. I right mouse click, select assignments, and then right mouse click, invisible. So we can see the bottom here. We return to top view and drag the mesh down. And now we see that we have the same x-axis, sorry. We turn on the surface axis and drag the geometry down here. So the x-axis is, the double arrow is going this way. Is it the same x-axis of this model? So we can directly compare the stress of a section perpendicular to the x direction. This is also the direction of the reinforcement in x direction. So we activate the value, stress top SX 0 decimal, Korean EU 24. So I keep the applying. No, okay, here. Then we go to this bottom and select element node to see the results here. Maybe it's better to show it bold, bigger. So because the model is totally symmetric in dead low, so we have the same stress value as x direction. It's a 1.96 megapascal. So it's a double as the values we have for the cone wall support. Of course, the final stress we interest is much bigger, but the test in the dead low is good to confirm the model is correct before we look at the results with loads on the wind turbine in the next tutorial. Thank you for your attention.